Hello, my name is Alexandre Bergel, and together with Felipe and Geoffrey, we are from the University of Chile. So this presentation is about automatically improving the performance of a Java application by automatically tuning the configuration of the Java virtual machine. So the Java virtual machine is between the operating systems and the Java application. And the Java virtual machine is a pretty complex piece of software, and it is in charge of managing the memory, making sure that the just-in-time compilation, which is the compilation process occurring while the application is being run, is correctly performed, and also monitoring various aspects of the runtime. So the Java virtual machines provide more than 500 different tuning flags to control very accurately many aspects of those, many details of those aspects, such as the garbage collection, the various parameters about the heap, how it has to grow, how it has to shrink, and the just-in-time compiler. So the flags of the Java virtual machines, they do matter for performance. If you have an incorrect set of flags, then your application might go slower than what you would expect. So the flags offered by the Java virtual machines are very complex to configure. So here, this is an example of the set of flags that are necessary to run a Minecraft server. The Minecraft server application written in Java needs a JVM, and in order to make sure that the player of the Minecraft they are happy about the performance of the server, then you need to have the set of flags. So here, those are the flags that the developers of the Minecraft server they've used. So as you can see, this is a bit cryptic, So after after many weeks of studying the Java virtual machines, studying the flags, and testing various configuration, the authors say that they really require tons of effort to make it happen. To make sure that they have a configuration that is adequate. So this illustrates the difficulties of configuring adequately the Java virtual machines. So in the latest version of the Java virtual machines, there are 528 flags and options to configure the Java virtual machines. So the set of flags that you need to provide naturally depends heavily on the application to be run. The flags that I've shown for the Minecraft server will not be the same that if you want to run a different game, for example, or different application. So the flags depends heavily on the application to be used. And some of the flags, they require some parameters. Parameters could be strings, Boolean, integers, and understanding like which value of those parameters is adequate or not is very difficult. And maybe like the cause of the problems of maybe the cause of the difficulties of configuring the Java virtual machine is a very poor documentation about the flags. If you take the official documentation, then it's very, it assumes a lot of knowledge about internals of the Java virtual machines. For example, you have the options, allocation, spikes, tolerance. I mean, which kind of value do I need to provide to those flags? I mean, it's not really clear just by reading the documentation. And also it happens that there are some dependencies, some hidden dependency between some flags. For example, if you have the flags G1 heap region size, these flags only make sense if you have the other flags use G1 GC activated. And even though like this is something maybe you could infer by guessing that these two flags, they are about the G1 garbage collector, and maybe you want to set the heap region only if the garbage collector is enabled. For some other flags, this is not clear at all. Like for example, the survivor padding flags require the adaptive size to be set or not. I mean, the documentation doesn't mention about it, and the description of the flags also doesn't say much about that. So this paper is a very simple solution that addresses those problems. So this paper is about automatically tuning the Java application to improve execution time. And the idea is to search a set of adequate flags and the parameters. So to achieve that goals, we provide a feature model of flags to express the constraints, and then we feed the benchmarks and these feature models to a genetic algorithm. And the genetic algorithm will find for an optimal configuration. So a few words about the genetic algorithm. So the genetic algorithm is an algorithm that comes from the machine learning world, and it is a computational metaphor of the natural selection that happens in nature. So we have a set of population that is composed of individuals, and some of the individuals that will perform badly, and some will perform good. So there is a selection mechanism. Some of the individuals are selected. Once they are selected, the genetic information is combined using some genetic operations, such as the mutation and the crossover. And then we can provide, by using genetic operation, we can create new individuals. And those individuals, they will replace the population. So here there is a cycle, and on some point, the cycle is ended when the algorithm has to end. And that could be very arbitrary, for example, a number of generation or times, to let the algorithm execute. There are many factors that could indicate that the algorithm has to be done. So applied to the Java virtual machines, each blue dot here is a sequence of flags. Okay, so this is really a sequence of all the flags that can be used in the JVM. So the performance of an individual is obtained by running the benchmark with those flags. Okay, so for one blue dot here, we are running the benchmarks, and then we identify what are the times to execute that benchmark. And then the selection picks the best configuration that reduces the most the execution time, and then we combine them, and then we iterate over the population B content. So we have the following workflow of work. So we first made a manual revision of the flags. Okay, or the 528 flags we read and searched for documentation for each of them. When the official documentation was not enough, then we looked on forum, Stack Overflow, logs, or we even read the source code of the virtual machine, which is open source. And with all, as a result, we build the feature model, and the feature model that contains some of the constraints. And on the other hand, we have a set of benchmarks, and we feed the benchmarks together with the feature model to the genetic algorithm. And the genetic algorithm is able to identify the flags that minimize the execution times of the provided benchmark. So here we have one result, which is the feature model. So we built that feature model, and we use the same notation that is commonly used in the software product lines. And here we have also the constraints. Those constraints are very important to make sure that the configuration that we are building makes sense and it is not broken. This work, our work is, our paper is a short paper, so we only focus on the garbage collection flags. Okay, so the feature model so far is restricted to the garbage collector, and the benchmarks are for only on the Dakapo. And then, as a result, we have this table. This table says that here we have the list of the benchmarks. Here we have the default default execution time. So this is the execution time of the benchmark with no flags. And then here, this is the execution of the benchmark by using the flags that were indicated by the genetic algorithm. And then we see that there is quite some improvement. The improvement range from 1 to 3% until 23% improvement. Whenever we want to measure the execution times, then there is a lot of noises, and by using some statistical tests, we show that the improvement are not pure luck. So as a result, we have provided an automatically approach to automatically optimize the Java virtual machine flags for a specific application. We use a feature model to express dependencies and avoid broken configuration. And we use a genetic algorithm to search for an optimal configuration. And this gave us really some promising results. As the future work, we plan to extend to the whole set of flags and not just the garbage collector, and compare against the related work, and also operate with additional benchmarks. And yeah, so that is our presentation. So thank you very much for having followed. Thank you.